Hope you guys are able to see the screen, guys.
Yes, sir. Yes, sir. Yes, sir.
Yeah. So this is what. So on the first cycle, you're going to learn about the source of water supply, and this second part is just a skip because it goes into treatment. But usually, treatment of water treatment goes on the later part. But yeah, not a problem. We just have a look into them. And then we go on how about designing sumps, then about various types of pumps used in plumbing, hydropneumatic systems, pipes, various pipe systems. On the second cycle, it's about water distribution from the building top, and it comes into part of the traps, mixers, closets, sanitary fittings. Third cycle, we go into fixtures. How about reusing wastewater, which is the gray water and the black water considerations, septic tank, water treatment systems. And then in the middle of the third part, we go about in learning about solid waste management. How about we going to take care of them? What are the various treatment methods available? How this disposal is done? So this would be looked in here. Fourth cycle, yes, it goes on the advanced technology of waste management. And then in the middle of fourth cycle, we start off with the fire safety, and it goes till the fifth cycle. So this is what we'll be covering for this semester's building service 1. And yes, so for today's class, what we'll be learning about is the prime importance of water. It's not about just plumbing. This is on a very general topic of what are the sources of water available and how much of this sources can be potable. Potable is drinkable water. We do have a wide coverage of water across the globe, but all of it is not usable. And how this quality of water varies from each physical property of water with minerals content to it, metal contents to it, salts, dissolved solutions, and all of that. So, yes, share you the screen now. Okay, is able to see? Is able to see now?
Yes, sir.
Yes, sir.
Yes, yeah.
Yes, sir.
So the molecules of water has been discussed here on what is the composition H2O, and this is another general coverage of what is the total amount of water available, as in like potable, the fresh water which can be potable, drinkable, which is just 3%. Whether the rest of the water has got various other properties to it. So, two-thirds of the water is tied up in the polar region. So, the ice caps, which is what we are again facing a danger of global warming, where the ice caps are melting and we might have a water level rise from the oceans. And how the global freshwater distribution is 0.4% comes on the lakes, rivers, and the soil moisture, which is the holding. And the groundwater is 25.6%. The ice caps, they contribute to the 74%. Remember, the ice cap is 74% is we can't use them. So what is available and what we can rejuvenate which means in terms of water harvesting, rainwater collection, all of this is what we look into. This is a hydrological cycle on how this we would have gone through from our basics of environmental sciences, that how we can water gets generated from the oceans, it evaporates, it goes into the it evaporates, rises above, it condenses again, the rainfall happens, then water runoff, and then again it goes into various storages. The meanwhile, it distributes to the ground level and refills the water aquifers also. So in this, you see what are the various methods in which the water rises up. Evaporation, this is from the example is from the extreme left, it's from the ocean, next from a pond. And then the trees. Trees play a very vital role in water distribution. They enable something called transpiration. Transpiration is nothing but water absorbed from the root goes up to the barks and stems and it evaporates through the leaves. This is one important factor. I guess you guys would have heard of saying, where there are no trees, there are no going to be any rain. Don't cut down trees. There won't be any rain. The reason why our ancestors used to tell that is because the trees play a vital role in maintaining the groundwater table. If the trees are not there, the groundwater, which is on the submerged level, it's not going to come up the water table because the roots are not going to be pulling up water. So that's the reason we say the trees are quite an essential part in a water cycle, transpiration. And how it comes down. So the three methods it goes up. How the water comes down is a condensation as clouds. Then it comes into as a rainfall through precipitation. Precipitation or rainfall is the same. And then when the water reaches the ground, it infiltrates. It just percolates. It starts to go down. So the hydrological cycle consists of 4 key components: precipitation, water runoff, storage, and transpiration, evapotranspiration. transpiration. We can just say transpiration, it's good enough.
டிரான்ஸ்பிரேஷன்னா மரத்துல இருந்து தண்ணி முடியுது.
So then we come in precipitation. Precipitation is the rainfall. How the water vapor gets condensed as clouds and come down. So these are the various types of precipitation, the rain. Cyclonic precipitation is once caused due to the cyclones where the pressure plays an important role in the building up of the clouds. Convective precipitation is nothing but due to the rotation of the earth, the clouds move around with the currents, and convective. Orographic means it is through the natural barriers, like the Western Ghats. If you take, for example, Kerala gets a very good rainfall because it's got a barrier of the Western Ghats, the mountains, which hold the clouds, and we get the rainfall. So these are the various rainfall methods. Water runoff is a surface runoff. So surface runoff, how we can capture them and we can use it, which comes into of rivers, ponds, filling up of water bodies, and all of this. This talks about the storage, where the storage means water. There are two methods of storage. There is a storage above the ground, which is the ponds and the lakes. And the storage below is through percolation, where we let the water to percolate, go through the soil. This is about transpiration, which I've already explained. The transpiration is the process of the roots absorbing the water, taking up to the barks, and the leaves enable the process of evaporation where the water gets in. Meteoric. It's not much. So here it gives a graphical representation of the water sources as a general method. What are the various which we already discussed? How the streams get into the water runoff, which leads into the ocean. Here's again a graphical distribution of the amount of water distributed across above surface and the below surface. Surface water, groundwater, conservation. This is it's more than the distribution. It's how generally we use it for consumption. Conservation is about holding up water in dams. Reuse is about treating of grey water and reusing them. Desalination is again a reuse, but here it is reuse for the purpose of potable and others, which can be black water. So here, again, as I said about the various water systems, surface water sources, rivers, streams, lakes, ponds, reservoirs, subsurface, springs, wells, infiltration galleries. Artisan wells are natural wells, dug wells, tube wells, infiltration wells. Infiltration wells is wells which have their own curing properties, shallow wells and deep wells. Uh, these are very gentle. So I think so. These are the introduction of source of water supply. Now it's about the discussion. They ask about what is the traditional water distribution methods. So what are the water distribution methods you have known, as in like how water has been distributed across? You guys have gone through few of the civilization from history, where how settlements started close to water bodies. I hope you would have come across some part of distribution in them. Any understanding on that, guys? You have to participate.
So canals.
Canals, yes. But what is the principle of canals, Niveda? Now, how does it work?
You divert the main stream, that is the river or anything, towards your irrigation sites or towards your settlement area, and the water flows through those diversions. Those are
Yes,
the canals.
perfect. So one thing you have to be very clear about the canal system is it goes through the current, and the current, which is the stream, the water flow, and then through the gravity. So normally when the canals are dug, it goes on to a hierarchy. It goes through a slope. Then that's when the water flows through. That is one. And again, in the earlier system, if you observe, there is another method where the wheels, the rotor wheels, are water is taken through buckets and forced out, which leads to the very primitive forms of pumps. Very primitive. So that is again a force method. So these have been adopted, and that's how the later system, the current systems, what we use, we either use the gravity flow system, where water from a higher region is brought down, it's distributed, and it's been utilized. So this you can take it as from a town, others you can take it as from a building perspective also. But again, in the buildings, what we do is we use pumps to take them higher, and then we distribute it. But imagine if you're on a foothills, even in a hill station, normally the higher water body, a water source, would be taken down through canals or pipes, and then they'll be distributed. So these are few examples. There are various other methods also. And then the pumps come in, and the pumps play a major vital role in a lot of these skyscrapers and tall buildings what you're working on now. And even for the single story house also. So that's about the water distribution, the traditional water distribution methods. Um, Next is any queries, guys, as of now? Anything what you have as questions? Anything what you want to discuss, which probably I have missed out, which you want to say? You can share your thoughts also. If at all you are thinking about some system which I'm not mentioned as of now.
Sir, aqueducts, sir.
Aqueducts, yes, aqueducts is a very good point. That's again, whereas in the canals it's done on the surface level. Aqueducts is the earlier European the systems where the pipe ducts are being exposed, and again that uses the principles of gravity. From a higher source, a gradual, very gradual source slope is taken up, and the same thing has been carried on in various parts. I think initially it started off in the European part, and even palaces in India have a few of them do have traces of aqueducts used for water transportation. Yes, good. Anything you want to say? Anyone else? Okay. So for the introduction, there's another thing what we need to look into is a syllabus says about conventional water treatments. So this treatment is not about sewage treatment, but it can be about a water which is not clear, a turbid water, a dirty water. See what happens when rain comes in, the water runoff happens. It goes through the soil, it collects the dust, it collects mud, and all of this is a natural process. But what are the conventional treatment methods which are being available, and is what we are going to discuss. So, as per the syllabus, what has been suggested is sedimentation, coagulation, filtration, and disinfection. Yes. Sedimentation, yes. What is about sedimentation is it's about a process where imagine you have a water runoff through a river and it's carrying all the sand, silt. Sedimentation is nothing but a process of water is made to rest in a place, and it's less to settle down, whether all the heavy particles go down and settle, and then the water is on the top level is being used for. This is one of the basic sedimentation process. Coagulation process is nothing but use of another material to bind or hold all the heavy particles together so they coagulate. Coagulate is nothing but to bind together. And again, what happens when they bind together? They bind together, either they float or they go down. Depends upon what type of material we are looking into. And with that, the segregation happens on the water. The next is about, just what is that? Filtration and disinfection. Filtration and disinfection is filtration is through how we the very easy example what we can relate to is if you have been looking into your rainwater storage in our homes itself, what we would have done is we would have done a percolation pit. The percolation pit is not just an empty pit, but it got stones and rocks. So what happens is these are stones and rocks which are stationary. So when the water moves through them, again the heavy particles get held up in the top part, and only the much more clearer water goes through. So this is one of the earlier filtration methods, wherein is they call it the sand filter method, where the water is being allowed to pour through a sand, and then the water is being filtered out. So what happens? The water goes through all these tiny rocks, and the heavy particles get held up between them, and just the pure water comes in. I won't say it's pure water, much more cleaner water than what the source water is. Disinfection is again through various methods. There are natural methods wherein like the earlier disinfection is the leaves are being used into water, thrown into the waters, which are allowed to submerge and percolate through the water. And that is one filtration. Then heat is another one disinfection method. If at all, you guys have been hearing about almond trees, what we see very common here in India. The almond trees leaves. If you see these dried leaves, they have a very good property of when they have been allowed to soak into the water, they neutralize the water. So these are various disinfection methods. So all of this part is just a general idea on how the earlier system started, and with the new technology and what we are currently going through is all the advancements from these primitives is what we look into it. And I'll just share you the last part of the syllabus contains, as in for the today's class, the qualities of a potable water. So what are the qualities expected of potable water? Sharing your screen. So, yes, this is from the Indian standards, the characteristics of drinking water. Actually, this is from one source I picked up. If you look into this book, just quickly, because more than this information, what I've got, this book has got a much more better standards. I shared you these standards in WhatsApp. Here, what you see is we just have a characteristics of Indian standards, whereas in the book, this is from the Rangwala's book. There's a mention about what is the international standards of drinking water, and they add a comparison again with the Indian standards. But here, the Indian standards, what they have made a reference is of 1983. But what you see on the screen is of the much more recent 1991. The Indian standards, what they have mentioned. You can just have a read through of these contents on what are these properties they are mentioned about. What is the colors, order, turbidity. Turbidity is about the cleanness or the transparency of the water. pH value suggested the hardness quality. And again, now it goes to the various minerals and solvents in the water. You don't need to buy out anything from this. It's just for a reference. So you just have an understanding of this. So these all play a vital role in making it into a potable water, which is a drinking water. So a lot of us, again, when we buy water from, we say it's a bottled water, but we don't see a lot of these properties listed out in any of the bottled waters. We just say, okay, it's a much cleaner water, but there are so many criteria which goes into making the water safe and much more palatable. Palatable is about taste. We say water is tasteless, but it needs a few minerals. If at all you're going to take in water without any minerals, it's not going to be palatable. Is about the taste form. It's not going to be pleasant. I won't say it's not going to be pleasant. We won't be able to quench our thirst with that. So Just go through a reading with the contents what I've just given. I have an understanding of them. So that would be fine. So any queries, guys? Anything on today's session? Not able to see anyone here. Anything which you didn't understand, you want me to rephrase or repeat?
Sir,
Yeah, Musha.
sir, could you please explain the drinking water standards? I didn't understand what it is actually.
Just a minute, yes. No, drinking water standards. Okay. There is a parameters. There are various parameters required for drinking water, Musham. So there are unit systems which scientifically they use as phi is a color unit system. Technically, if you go through, phi is acceptable standard and 25. I'm not sure what is the benchmark difference they are looking from top to bottom, but they say in a report, if at all you're getting a report scientifically tested, phi is a unit maximum of for the color quantity. And for order is about smell. It's unobjectional. Unobjectional means you're not getting any smell out of it. So no influence or no trace of anything. It could be an organic or inorganic compound. Taste is agreeable. These are very general definitions. Turbidity is again a value. In a scientific evaluation, they have kept a value of 5 is fine. But the permissible limit still, the requirement is 5. But it is still fine if it's 10. 10 means the turbidity is more, but even 10 is fine. Similarly, for the color, the required standard essential is 5, but the permissible, what is mentioned here, is 25. These are all of Indian standards. pH is strictly 6.5 to 8.5. That's what they have mentioned in the permissible limit. There's no relaxation. There can't be either it can't go below 6.5 or it can't be above 8.5. Hardness is nothing about, it's about the dissolved contents what's in the water. 300 is the required, the maximum required, but the hardness is much lesser also, it's fine. But the permissible limit is 600. And again, we have about all the various minerals and metals. Here, the minerals is about your metal, iron. It says about 0.3 milligrams per liter is fine. But if you see what is permissible, what is allowed, you can go up till 1 milligram per liter. 0.3 is the required, but you can still, even if it's till 1 mg per liter, it's fine. So that's a comparison of this whole chart. Whereas if you look into the WhatsApp of what I've sent you, that would have a comparison of World Health Organization standards, WHO standards, compared with the Indian standards. Is that fine, Musham?
Yeah, so these are like characters, right? Involved in the water.
Yes, these are standards expected. You can't go above them,
got it, sir.
which makes it not safe for drinking.
Yeah, got it, sir. Thank you.
Yes. Anything else, guys? Any other questions? Did you guys receive the WhatsApp message?
Yes, sir. Yes, sir.
Yeah, fine. Just have a glance of it. You don't need to memorize anything, but just have an understanding. It's more like just a basic knowledge of what is the process it goes through. So in the later classes, what we look into is when we analyze what are the qualities of water we can use and what are the waters which can be segregated and used. So we can be very sure of defining example. Um, we have a lot of houses, we have sumps for water storage, which later we'll take it up to the sump water is what we take, either we get it from the groundwater, we might probably hire a lorry water supply from outside and store it. Whereas we'll have another secondary sump where we'll have a rainwater storage. The reason why there is a segregation here is The water property, what we take from groundwater and property from the other source of lorry, it has got a different properties of characteristic, whereas the water from the rain, which is the runoff water, which will have a different categories because it goes through all the surfaces and it might carry some dirt also. So we don't want to mix them up together. So again, how the characteristics play a very important role in segregation, and we designing these spaces accordingly. Fine. Guys, I've opened up the GCR also for this. Sorry, I didn't give you the link. Sorry, I just sent you the link also. Please join the class, all of you, and mark your attendance there. So as of now, there are 54 students here. I think 14 are not here.